Get my arm out of there, sorry. Hello, hey there, Algebra 2. This is the lesson on composition of function. This is a kind of something extra in the book. It's not necessarily out of a chapter. I honestly should have covered it earlier, but we're getting to it right now. A composition, composing. If you're composing something, you're creating something. You're putting stuff together. So a composition is when you put two or more functions that are combined. Okay, so I don't have any student journal notes with this. It's just two or more functions that are combined. So let's say f of x, this is a function, is 2x plus 7. And let's say g of x is x squared plus 2. So remember, with a function, if we just want f of 4, I replaced the x with a 4, so everywhere I see an x, I have to replace it with a 4. So 2 times 4 plus 7, so 8 plus 7 is 15, so that'd be f of 4 is 15. So what a composition is it looks like this. It's f of g of x. So it's another function evaluated at a function. So f of g of x. So just like this 4 replaced the x, g of x, this function, is replacing the independent variable in f. So what is g of x? G of x is x squared plus 2. Okay, so g of x equals x squared plus 2. So if two things are equal, you can substitute one for another. So f of g of x is f of x squared plus 2. Now f of x is 2x plus 7. So that'd be 2. Now instead of an x, we have to substitute whatever's in this parenthesis. Whatever's in the parenthesis is going for the x. So x squared plus 2 plus 7. So just like whatever is in the parenthesis took the place of the variable, whatever's in the parenthesis took the place of the variable. Okay, distribute 2x squared plus 4 plus 7, and then 2x squared plus 11. That would be your answer. Okay, it's not a specific value, it's an answer. But they could give you now, okay, what is f of g of 8? Okay, so now we have a function for f of g. This is read f of g of 8. So this would be 2 times 8 squared plus 11. So that's 2 times 64 plus 11. That'd be 128 plus 11, so that'd be 139. Okay, that's one way to do it. The other way is if you have f of g of 8, what is g of 8? Well, g of 8 would be g of 8. Remember, that is x squared plus 2 from above. G of x is x squared plus 2. So that'd be 8 squared plus 2, which is 66. So g of 8 is 66. We can replace that back here. G of 8 is 66, the number 66. So f of 66 now would be 2 times 66 plus 7, which is 132 plus 7, which is 139. We get the same answer. Okay, and you should be getting the same answer with both of those. Okay, so let's go the other way. Let's go g of f of 3. Okay, so I'm going to do this inside one first. What is f of 3? Well, f of 3, remember, that's 2x plus 7, so 2 times 3 plus 7. So 6 plus 7 is 13. Come back, replace it right there. G of 13 would be 13 squared plus 2. That's 169 plus 2. That's 171. So g of 13 would be 171. Okay. So when you have these functions, you're going to plug that in the first one first. So do g of 8, and then take it into the outside function. So inside to outside is what you're working here, inside to outside. You can double these up too. You can say f of 10. Okay. So that would be, okay, what is f of 10? That's the inside. I'm doing that first. Okay, f of x is 2x plus 7, so that's 2 times 10 plus 7. That'd be 27. Come here, replace that. So now we have the outside one, f of 27. That is 2 times 27 plus 7. That'd be 54 plus 7 equals 61. So that answer would be 61. What about f? Okay, before I do that, this notation can also look a little different. They can use this symbol right here, an open circle, f of 7. This is an open circle, and it means composed of. This is a new operator for you. So just like you learned the plus sign, minus sign years and years ago, multiplication sign, division sign years and years ago. Okay? This open circle right here means composed of. So f composed of f, that means this symbol right here. Okay? So you're going to see some, let's see, make sure I got your assignment here. So they say, okay, let f of x equal 3x to the negative 1, and g of x equals 5x minus 1. What is g of f of x? And then it's going to ask for the domain. So g composed of f of x. How this is written is g of f of x. Okay. So this would be g of, now I'm going to rewrite this, 3x to the negative 1. Remember, a negative exponent is reciprocal. It is just on the x. It's not on the 3. So g of 3 over x. G of 3 over x. So g is 5x minus 1, so this is 5. Replace the x with 3 over x minus 1, and we're going to get 15 over x minus 1. That 5 is not distributed to the 1 because the 1 and the 5 come from the g function. Okay. Our domain, okay, x cannot equal 0, because remember, 0 in the denominator is undefined. So if you go back and look at your domains here, x cannot equal 0 here, but on this one, x can equal all reals. Okay. So when you put them together, if x can't equal 0 on this one, and you're using this function, inside this function, x still can equal 0. Okay? Okay, so let's go the other way. Let's go f of g of x. So that would be f of g of x, like that. So the g goes inside the f. The g is going inside the f. Kind of work right to left with this. So what is g of x? So that is 5x minus 1. So f of 5x minus 1. So f is 3 over x. So this is 3 over 5x minus 1. So now, you look at your denominator. Remember, 5x minus 1 cannot equal 0. So 5x cannot equal 1, so x cannot equal 1/5. That's your domain restrictions. So for your domain, they will say, you would say all real numbers except x equals 1/5. So that's how it's going to be worded. Okay, I'll bring that over here. All real numbers except x equals 1/5. So here are your two different functions. Remember, 2x to the negative 1 is 2 over x. Domain, it'd be something like all real numbers except. That's how it's kind of worded there. So 2x to the negative 1 shows up several times through here. Same functions. Okay. So here's a duplicate one, h of x. That's when you take h of x and you plug it into itself. Now this is just a linear function, so that domain should be all real numbers. Okay, so if you have linear functions, it's going to be all real numbers. f of x. Okay, let's look at that one, and then I need to go to a class. So let's say we have f of x. Well, that would be f of 3 over x. So that's weird because you're going to put 3 over x into itself. So it's going to look like 3 over x. And how you clean that up, this is division. This is 3 divided by 3 over x. Okay? So how you divide is I'm going to multiply, cross multiply 3 times x over 3. So that's a KFC. I don't like that slogan, keep, flip, change. So 3 divided by a fraction would be 3 times x over 3. So this x basically goes up there with that. And you get 3x over 3. The 3's cancel. You actually just get x in this case. Now you may look into that and say, hey, your domain can be all real numbers. But it can't, because go back to the work that you did. On these original functions, remember x cannot equal 0, so that would be part of your domain restrictions there. X cannot equal 0. So that's the quick with the composition of functions. There are several applications to this we won't get into right now. Good luck with this. Hope it goes well, and I will see you soon. And feel free to ask questions and bring any questions that you have. So we'll talk to you later.